We are asked, is a conic section with foci at f sub 1, and they give the coordinates, and f sub 2, and these coordinates, and points at p1 and p2 with these corresponding coordinates, an ellipse, a hyperbola, or both? Why or why not? Pause this video, have a go at that before we do this together. All right, so let's just remind ourselves, if we're dealing with an ellipse, then we know that the distance from p1 to f1 plus the distance from p1 to f2, so the sum of the distances of p1 to the different foci, that should be equal to the sum of the distances for point 2. So from p2 to f1 and from p2 to f2. Now, if we're dealing with a hyperbola, so let me write that over here. So the hyperbola case, hyperbola, instead of a sum, we're looking at the difference, and we're looking at the absolute value of the difference of the distances. So in the hyperbola situation, we're going to have the distance from P1 to F1 minus the distance from P1 to F2, and we just care about the absolute value of it. We want this to be positive. That needs to be equal to the absolute value of the differences of the distances from P2 to the foci. So plus D, P2, and F2. And we're done. My hand is hurting, all that notation. So what you have to do is just figure out these things. And we don't have to figure out 8 things. You only have to figure out 4 of these, and then we can look at them in each of these cases. So first, let's look at the distance from P1 to F1. So that's going to be, I'll just do it right over here, it's going to be the square root of our difference in x values. So it's going to be 0 minus 1 squared. This is just the distance formula. And then plus the difference in y values, so 1 minus 0 squared. 1 minus 0 squared. Well, this is just going to be 1 plus 1 square root. So this is just going to be the square root of 2. So that's the square root of 2. And by the way, this is also right over here, the square root of 2. And now this one over here, distance from P1 to F2. Well, same idea. Let's see, from P1 to F2. So we have 0 minus negative 1, 0 minus negative 1 squared. And then we have plus 1 minus 0 squared, 1 minus 0 squared. Well, this is just going to be 1. This is going to be 1 squared. Well, 1 squared plus 1 squared is just 2. And so this is, once again, going to be square root of 2. So the left-hand side over here has added up to 2 times the square root of 2. And in this situation down here, this was the square root of 2. So the left-hand side, the difference, the absolute value of the difference over here is just going to be 0. Now let's do the right-hand sides, and I'm going to find more colors. So the square root of P2, 0, 1, so 0 minus 1 squared plus plus negative 1 minus 0 squared. Negative 1 minus 0 squared. Well, once again, this is 1, this is 1. You square them, you still get 1s. You add them, you get a 2. So this is going to be square root of 2. This is also right over here, square root of 2. And then last but not least, this piece right over here. I'm sensing a pattern. So we see, let's see, we're going from 0 to negative 1. So 0 minus negative 1 squared plus negative 1 minus 0 squared. So same idea. This all simplifies to square root of 2. So this is also square root of 2. So in this top scenario, this is 2 square roots of 2. So the sum of the distances from each of the points to the 2 foci, they are actually the same. So these 2 points could be on an ellipse, but we also see the difference of the distances from each point to the foci. It stays constant. So they could also be on a hyperbola. So this is a case where the same set of 2 points could be on an ellipse or a hyperbola. And so you could imagine if you were to construct an ellipse that has those 2 points and a hyperbola that had those 2 points, those would be 2 points where those 2 where those two conic sections would actually intersect.